Hi everybody, and welcome back to our third video. And when we left off, we were comparing NPV projects, net present value projects. And here we're going to use the profitability index to rank projects of a similar initial investment amount and risk levels. So how we do that is we take the present value of all the cash inflows, and divide it by our initial investment. And as you see by these examples here, we have 1.2, 1.5, and 0.9. And we will select the project that has the highest profitability index, which in this case is project 2. But project 3 had a profitability index that was less than 1. So we would not invest in project 3 because it would have a negative net present value had we calculated net present value for that project. The profitability index is great for evaluate if you have a lot of projects and you want to stack rank them. And that's how we would use it. Okay, internal rate of return. This is the other one that I believe is very useful in evaluating projects. To be honest with you, I use simple payback. I use profitability index. I should say net present value and internal rate of return. Okay, the definition of internal rate of return, very important. It's that discount rate that yields a net present value of 0. You will see that very graphically illustrated when I go through my last video and use Excel to calculate net present value and internal rate of return. But for right now, understand that if we increase our discount rate, we're going to reduce the present values. And as we reduce the present values, eventually, if we have a high enough discount rate, it will result in 0. And that is the discount rate, that's the internal rate of return. Okay, so here we're going to compute the present value factor for an investment project. And here's our present value factor and our initial investment and our annual net cash flows. You can see that they had a little problem with spelling, but we could adjust for that. Then we're going to identify the discount rate yielding the present value factor. So let's take a look at that. If we have equal cash flows, we can compute the present value factor for the investment of the project by taking our present value, our initial investment, and divide that by our annual net cash flows. And that gives us a 2.4018. And then we can go into the tables for the present value of an annuity for 3 periods, because this was 3 years, and we go find that where that discount rate that comes closest to the present value factor is. And in this case, they make it easy for us because it comes out exactly 12%. That's extremely rare, I might add, but nevertheless, this is a complicated calculation, and I'll show you how to do it when we get to the Excel spreadsheet. Now, when we have unequal cash flows, it becomes even more complex. So, when we use internal rate of return to evaluate a project, we're going to compare that internal rate of return from that predetermined acceptable rate of return, hurdle rate, discount rate that we've been using. And we will measure it, the internal rate of return, how much, if it's a go project, how much greater it is than the hurdle rate. Okay, so here's our internal rate of return. It's greater than the hurdle rate, so we've invested in that. If the internal rate of return is less than the hurdle rate, then we're not going to invest in that. So if we look at all these methods that we've just gone through and look at them in a big picture standpoint, we'll take a look first at our net present value. Here we're using cash flows. That's good in my view, as we do with payback period. Net present value is going to give you a dollar return, whereas internal rate of return will give you a percentage return. This net present value is going to reflect the time value of money, and it's going to reflect changing risks over the project's life. And it's a little harder to compare projects because we're dealing with cash flows and not percentages. But with internal rate of return, it also reflects time value of money and an easier comparison of projects because it's comparing percentages. And it ignores the changing risks of project's life. Okay, and then our payback period we've already gone through. But the accounting rate of return, the focus is on income, not cash flows. In my view, a weakness. It yields a percentage. It's easy to compute, but it does ignore the time value of money, and it does ignore cash flows. Serious weaknesses in my view. Okay, let's take a look at break-even time. Now, break-even time is very similar to payback period. The difference is, instead of using undiscounted cash flows, we use discounted cash flows. But we have to have a cumulative column. So here's the present value of all our cash flows, and here's the cumulative present value of those cash flows. And here, as you see, is our break-even time, somewhere between year 3 and year 4. So what we're going to do is we're going to take, and of course our present value is 3541. So what we're going to do is we're going to take this 1805 as a percentage of 2800. And that's going to give us what percentage of year 3 we're going to add to year 3 to get our break-even time. All right, using Excel to compute internal rate of return. Now, I do it a little bit differently, as you will see, but Excel does have functions that make these calculations pretty easy. Now, here is our initial investment of $16,000, and then here's our annual cash ends. So they use this function here, IRR, and they use this range from C1 to C10. And that will give them the internal rate of return. Actually, they're a little bit in error here on this spreadsheet because they shouldn't have left row 2 blank. This should all be contiguous if you actually use this function for internal rate of return. But computing present value and internal rate of returns for projects with uneven cash flows is tedious and error prone if you don't do it my way. And I'm going to show you my way, and you can evaluate if you want to use it or not. These calculations can be performed simply and accurately by using functions built into Excel. There's also a net present value function. If you use NPV, and if it would be equal sign NPV, and the range you're going to use is just the discountings here. And then at the very end of that, you would subtract 16,000. You would just have to know how to use the NPV function to know how to work that properly, which they don't show on this spreadsheet. But I think I do on mine. So at this point, we will stop this video, and when we return, we will get into my spreadsheet. Until then, bye for now.